Hey there, Prof. Aram here, and in this video I'm going to go over two more future value problems, and hopefully you get the chance to practice calculating the future value better. So make sure to pause the video and replicate my answer on your calculator or on the Excel sheet to make sure that you got the right answer. So let's get to this. Of course, this is a very hypothetical question, but it can be very interesting. So in 1626, Peter Minuit purchased all of the Manhattan Island from American Indians for just $24 worth of goods and jewelry. Assuming that American Indians had sold the goods and jewelry and invested the $24, earning 7% per year, how much would they have in 2023? The formula for future value is your PV times 1 plus the rate to the power of number of the periods. So your present value in this case is $24, and the rate you're earning is 7% raised to the power of 397. So it's 2023 minus 1626. So we have 397 years. So let's just do this on a calculator first. One thing that you need to do with the calculator is that you need to clear this time value of money function every time you use it, because it will remember whatever you had in the previous problem. So you need to do second FV to clear this. Even if you turn it off, it still remembers the numbers. So you have to do the second FV. Says on top of FV, you see CLR TVM, which is short for clear TVM. So second FV clears the time value of money function. So your N is going to be the number of years, 397. Your present value is $24. Because this is an investment, I'm going to put a negative sign here. And we have 7% rate of return. And we're going to compute future value. As you can see, the screen for the calculator is not big enough to show this number. So it's 1.1 times 10 to the power of 13. I think we have a better luck of seeing this number using Excel. So let's go over this problem. So we have year of the purchase 1626, present value would be $24, current year is 2023, rate is 7%, and the number of years would be 397, which is the difference between 2023 and 1926. So the future value would be the rate, which is 7%, number of periods, which is 397. We don't have anything for payment, so we just leave it empty. And the present value would be 24. If you notice, I have a negative number for the present value because this is an investment decision. So that would give me the future value of this number. To be honest with you, I don't do well with anything more than $1 billion. So just this number, okay? It's million, billion, $11 trillion. And to check your answer, we can do the formula 24 times the present value of $24, the interest rate is 1 plus the interest rate is 1.07, and raised to the power of 397. That should give us exactly the same answer. So it's very interesting to see, like, from 2022 to 2023 how much this number has changed. So future value of 7%, number of periods in this. For 2022, I'm gonna go ahead and enter 396, and present value is still 24. Actually, let's put negative 24, and then, ooh, what happened? What did I do? Oh, that's why. Instead of 7%, I had 70%. So that's why we got a crazy number here. So the difference between, let me just pull it back a little bit. So simply from last year to this year, the difference is $726 billion. So of course, this is a very hypothetical example, but it shows you what happens if you allow your money to stay invested, to stay in your account for a long period of time. Especially later in time in your investment, the money is going to grow exponentially. It's going to grow much faster than earlier in your investment. So let's look at another example. Suppose you have $500 to invest and you believe that you can earn 8% per year over the next 15 years. How much would you have using simple interest? So using simple interest, the future value would be the present value plus invested amount times the rate times the number of years. So we have 500 plus 500 times 8% times 15 periods. You will have 1100. So this is going to be 600. So together you will have $1,100, right? So how much would you have at the end of 15 years using compound interest? So we have present value times times 1 plus the rate raised to the power of t. So we have 500 times 1.08 raised to the power of 15. That should be 1,586.08. Right? Let's just do this in the financial calculator as well. The first thing I do, let's just do simple interest first. So we have 500 times 8% times 15 plus the original 500. That gives us 1,100. And for the time value of money formula, I'm going to clear the time value of money first. And then we do 15 years. So N is 15. 8% is the discount rate. And then we are investing $500. and then we compute future value, 1,586. You can also use Excel to solve this. %8 is the interest rate, 500 is the present value, and number of periods is 15. So we can do simple interest, which is the original amount, the 500, amount plus 500 times the rate times the number of periods. You should also get 1100. And then for the future value, we have 8% for the rate, 15 for the number of periods, no payment, and then the present value would be 500. Actually, it should have been negative, but it's fine. So you're getting 1,586.08 for the future value. So I hope you find this video useful, and thanks for watching.